It's time to introduce another model to your classification arsenal, logistic regression. Despite its name, logistic regression is used in classification problems, not regression problems. We won't go into the mathematical details here. See our stats courses for that, but we'll provide an intuition towards how logistic regression, or log-reg, works for binary classification. That is, when we have two possible labels for the target variable. Given one feature, log-reg will output a probability p with respect to the target variable. If p is greater than 0.5, we label the data as 1. If p is less than 0.5, we label it as 0. Note that log-reg produces a linear decision boundary. Using logistic regression in scikit-learn follows exactly the same formula that you now know so well. Perform the necessary imports, instantiate the classifier, split your data into training and test sets, fit the model on your training data, and predict on your test set. Here, we've used the voting data set that you worked with earlier in the course. Notice that in defining logistic regression, we've specified a threshold of 0.5 for the probability, a threshold that defines our model. Note that this is not particular for log-reg, but also could be used for KNN, for example. Now, what happens as we vary this threshold? In particular, what happens to the true positive and false positive rates as we vary the threshold? When the threshold equals 0, the model predicts 1 for all the data, which means the true positive rate is equal to the false positive rate is equal to 1. When the threshold equals 1, the model predicts 0 for all the data, which means that both true and false positive rates are 0. If we vary the threshold between these two extremes, we get a series of different false positive and true positive rates. The set of points we get when trying all possible thresholds is called the receiver operating characteristic curve, or ROC curve. To plot the ROC curve, we import ROC curve from sklearn.metrics. We then call the function ROC curve. The first argument is given by the actual labels, the second by the predicted probabilities. A word on this in a second. We unpack the results into three variables: false positive rate, FPR, true positive rate, TPR, and the thresholds. We can then plot the FPR and TPR using pyplot's plot function to produce a figure such as this. We used the predicted probabilities of the model, assigning a value of 1 to the observation in question. This is because to compute the ROC, we do not merely want the predictions on the test set, but we want the probability that our log-reg model outputs before using a threshold to predict the label. To do this, we apply the method predictProba to the model and pass it the test data. predictProba returns an array with two columns. Each column contains the probabilities for the respective target values. We choose the second column, the one with index 1, that is the probabilities of the predicted labels being 1.